Welcome back. Question number 6. Do not use a calculator in this question, which means although it might also appear in paper 2. Okay, this means you need to show, basically you need to show every single step in this. Okay, so in this question all lengths are in centimeters. So here is a right angle, the triangle is given. So again, I want to remind you, whenever it is a right angled triangle, make sure you guys use SOHCAHTOA. That's easier because you can also see the marks are 3 marks, so it's easier. SOHCAHTOA, I don't say you cannot use sine and cosine rule, but when you see the mark scheme always gives only SOHCAHTOA if it's a right angled triangle. Your answer will be still correct if you use sine and cosine rules. But I 100% recommend use SOHCAHTOA. Okay, so let's go into the question. In the diagram above, AC equal to square root of 3 minus 1, AB equal to square root of 3 plus 1, angle ABC is 15 degrees and angle CAB is 90 degrees. As I said just now, it's a right angle triangle. Now show that tan 15 degrees equal to 2 minus square root of 3. Okay, since here it's already saying that show that tan, which means we cannot use sine and the cosine rule anyway. Alright, so SOHCAHTOA. So we must use TOA, right? So this is opposite and this is adjacent, right? So tan 15 is equal to TOA opposite over hypotenuse. Sorry, opposite over adjacent. Okay, and you can see that the answer is already in a rationalized form. So we need to rationalize this. So using the a square minus b square formula. So if there is a plus, we need to times with the minus. So if a plus b is given, we need to times with a minus b. Make sure you do the same thing in the numerator. So this gives me, we know that square root of 3 times square root of 3 is a 3 minus 1 times 1 is a 1. Yeah, so this is basically a 2, right? Okay, so you see the numerator, this is square root of 3 minus 1 times square root of 3. So basically it's a square root of 3 minus 1 whole square, right? So a square, which is a 3, minus 2ab. 2ab is 2 square root of 3 plus b squared, so plus 1, right? So I will simplify this. This gives me 4 minus 2 square root 3. So I can simplify this further. 4 times 1, 4 times 2, and 2 times 1, 2 times 2, and 2 times 1 here again. So the final answer is 2 minus square root of 3, and we have shown already. Is it okay? So that completes our part A. Now let us see B. Question B. Find the exact length. Look at the keyword here. Exact length of BC. So since it's a right angle triangle, I'm going to use the Pythagorean theorem. A square plus b square equal to c square. So BC is going to be square root of 3 plus 1 whole square plus square root of 3 minus 1 whole square. And also you don't need to expand that all because we already did. Always you need to go back and forth. See, this one was already 3 minus square root of 3 minus 1 whole square. So I already have the half of the part of the answer here already. So I can write this one directly, 4 minus 2 square root 3. If a minus b whole square is 4 minus 2 square root 3, a plus b whole square will be 4 plus 2 square root 3. Makes sense, right? Right? Then BC is going to be, I'm going to simplify this. 4 plus 2 square root 3 plus 4 minus 2 square root 3. You can see that these both will be cancelled. Plus square root 3 and minus square root 3. The answer is square root of 8. So you can give answer as square root of 8, or you can further simplify to 2 square root 2. Don't write it in a 3 significant figure because they said it's exact value. So this must be our final answer. So here ends the question number 6. I'll see you in the next video for question number 7.